All right, extremely busy day for the old guy. I got about 20 minutes to do problems, 31 to 57. So let's have at it, because then I got to unlock the door and give a test. All right, conjugate 4 plus 5i over 6 minus 2i. So we're going to multiply by 6 plus 2i. That's going to get us 36 and 4, 40. That will give us 40. And I got to multiply by 6 plus 2i. Helpful if you put parentheses there, so grammatically correct. 4 times 6, 24. 5i times 2i, 10i squared. If I combine those, I get 14. I got 30i and 8i, 38i. Yasser, if I make a mistake, let me know. Here, this is checking if you know what to do with it. Well, that's the exponent you put on top of x. In order to get 4x plus 21, takes us to an Algebra 1 topic. X squared minus 4x minus 21 equals 0. So therefore, x minus 7 times x plus 3 gets us 0. Negative numbers cannot be the base of a logarithm. So the only answer here is x equals 7. If you plug it in, you'll see it's true. Cube root. Okay, I got to get an eraser here. So if the exponents are divisible by 3, it's a perfect cube. And if it's not divisible by 3, then we need the remainder. I got to erase these as we go because it is today's test. And I don't want it on the board when people come into the classroom. Cubes. 8, 27, 64, 125. In high school, you need to know those four. 27 is inside, so the cube root of 27 is 3. I can bring a 3 out, and I have to leave 3 in 27 times 2, so there's a 2 here. All right. X, not enough to write as something coming out of the radical sign. The cube root of y cubed is y, and the cube root of z to the 17th is z to the 15th times z squared. That's a perfect cube. So that's z to the 5, and I still have z squared in the radical. All right, let's get René Descartes up and running. I don't think I have to charge it up. I think it's ready to go. That's what I like about René Descartes. I don't have to plug him in at night. Did I miss? Oh yeah, I was about ready to skip some problems already. So now we're doing square roots. Well, the squares you need to know are 4, 9, 16, 25, etc. Be nice if you could get up to 121. You won't see much. 144 even is helpful to know. Square root of 144 is 12. You'll see that with ellipses and circles all over the place. So I can see 4 times 10. So I'm going to take a 2 out. X to the 8, I'm going to take an x to the 4 out. Y, not enough. Z to the 19, I'm going to take 9 of them out. That gets me to 18, so there's one more there. Then 4 times 10, so let's move the y over here. That's a z, folks. So that's a 10. I think that should be right. Point of inflection, I don't think you should wait till you get to calculus to learn about points of inflection. Concave down to concave up. All right, so what do we have for a point of inflection here? F of minus b over 3a. Boy, that should sound familiar. So minus b, minus 9, 3 times negative 3, negative 9, nice easy number, 1. I'm going to plug 1 in, and I hope I get a 3-to-1 ratio opposite sign, or I've made a mistake. Negative 3, positive 9. Oh, I like that, 3-to-1 and opposite. That should sound familiar, minus 10, minus 5. So point of inflection, 1 comma, minus 18, plus 9, minus 9 is what I'm getting, and I got a backup. So if I made a mistake, we'll put it into the introductory comments. All right, I'm hoping that we get a little sense of what this looks like. That critical number is 1/2, going up twice as fast as the typical square rooting process. X minus 2, so here we have maybe an x-axis here. X minus 2 is probably here, going up at 1-to-1. I'm pretty darn sure I only have one answer, but we'll get both and find out that the other one is probably near 1. But let's find out. 2x minus 1 equals x squared minus 4x plus 4. Again, hoping we binomial square that correctly. So 0 equals x squared minus 6x minus 1 goes to the other side, becomes positive 1, and becomes 5. So that's x minus 5 times x minus 1. Yeah, 1 was a good guess because that's the bottom half, but we're not graphing it because we want this to be a function. 1 does not work, but 5 seems to. I can always plug 1 in here. 2 minus 1 is 1, the square root of 1 is 1, and 1 minus 2 is negative 1. It almost works. Yeah, it almost does. All right, next problem. 7 plus 2. I hope some of you are at the point where you can just write x squared minus 14x, 7 and 49 and 4 is 53. Hope you can write that, because if you do completing the square, you get x minus 7 squared minus 49 plus 53 equals 0. Well, that's positive 4. It becomes negative 4 on the other side. What do you do when you take plus minus the square root of negative 4? Oh boy, start to get plus or minus 2i. Well, if I can complete the square and get answers, why can't I work backwards through those steps? Why don't I take away 7 on this side? Why don't I mark right minus plus minus 2i on that side? I think that comes from plus minus the square root of negative 4. And if I square that, I think I get negative 4. But let's do it this way. X minus 7 squared, x squared minus 14x plus 49 equals positive 4i squared. Okay, that's negative 4. So there's your x squared minus 14x plus 53 equals 0. Forwards and backwards, forwards and backwards. Hurrah! Sign of A. I don't know what was on the test. I know I forgot to put this on the test, so we've got a generic. Can you find the sign of that function? Can you see that that's 81? Can you see that that's 4? Okay, let's get rid of that. Let's remember it's 9. The 4 doesn't matter because we're looking at the sign, which is opposite over hypotenuse. So I know my answer is over 9. Can I find that square area? 81 minus 4 seems like it's 77, and it looks like that side length is then the square root of 77. I've got 3 y values here. The first one is 3, the most important one. How do I get from 3 to 11? I add 8. How do I get from 3 to 7? I add 4, not 8. I add 4, not 8. I don't care if you write 1/2. I'm checking out the concept. But I'll write 1/2. And now I've got linear function here. X minus 1890 all over the change, which is 34. Which happens to be the same as 1 over 34 times x minus 1890 over 34. So I'm going to stop there because I don't want to get into something but that's a linear function right here. And we know how to write the equation of lines. So I'm hoping that, if you had 1890 here, minus 1890, you see some similarity what's written here. Don't worry about that y out there. All right. So let's keep going. Got to get this done in another 10 minutes. F of x equals 2x minus 7 is a V shape where I'm going down from left to right, then up. Negative slope, positive slope. Where does it hinge? It hinges at 7. X minus 7 looks like that. If I slap that with an absolute value, all those negatives become positive. So that's where it hinges. So what do I have? I have f of x equals Alfred Hitchcock. Go back and look at some of the beginnings of his shows on TV. And I've got negative slope, so minus 2. X minus 7 plus 3 is the left-hand branch, and that's when x's are less than 7. And I'm going up to x minus 7 plus 3 for x's greater than or equal to 7. Geez, I wish I could see that 7 more easily. Oh, maybe I can. All right, so when am I greater than 11? No, I got to solve this for 11. All right, so let me erase this. I used to use those branches, but we are now really looking at the process. Subtract 3, divide by 2, take the plus minus, and add 7. And it would be nice if you said 11, and it would be nice if you said 3. What's in between 3 and 11? Oh, the number 7. Yeah, I think I can trust those answers. So now I'll put them on a number line, 3 and 11, and I'll say, what if I used 11? If I've used 11, I get 11. Is 11 greater than 11? I don't think so. So therefore, 3 is not going to work. That leaves 3 intervals, A, B, and C. Let's try any number bigger than 11. How about we try 12? Well, that's 5, 10, 13. Is 13 bigger than 11? True. Let's try 0. 0 gets me 14 plus 3 is 17. Oh yeah, 0 is less than 3. That's true. I meant to use something between these. Let's use 7. 7, oh, that gets rid of that. 3, is 3 bigger than 11? That's false. You know, I see a pattern here. Every time we've done this problem, they've alternated signs. Wonder why. I think we'll have to look at the midterm, after the midterm, as to how to know that and know it easily. All right, is there another question there? No, we just did 3. 5 more minutes. So how do I do this problem? I subtract 5. That's 27. I divide by 3. That's 9. I do the inverse of E. That's the ln of 9. And I add 4. 4 plus the ln of 9. Sure would be nice if you could figure out what that is. Ln of 3, 1.1, 2.2 plus 4. It's approximately 6.2. All right, hope I didn't make a mistake. No more problems there. All right, Renee, we got a roadblock here. We got to get rid of this board. All right, let's move this in front over here. Let's move this back. Let's move you here. All right, good enough. All right, so I hope you know you got to flip it. Then you got to take a square root. Cube root of 64, 4 to the negative 2, 4 to the negative 2, 1 over 16. Equation, 16 is 2 to the 4, and 8 is 2 to the 3. And if I raise that to 3x minus 4, then the exponential activity has to be the same. So let's get the bases out of there. That's 4 times 5x is 20x. That's 3 times 3x minus 4. Don't forget to multiply that by 3. So 9x minus 12. I'll bring the 9 this way. That's 11x equals minus 12. I think x is minus 12/11. Remember, Yasser, if I make any careless errors, you're my backup. All right. We got to get the other side of the world involved here. Yeah. All right. Anytime you see the exponents divisible by 3 and you have a difference, you can do the difference of 2 cubes. You really can do the difference of any 2 numbers and write it as the difference of 2 cubes, because you could put any number inside this and find what its cube root is. Anyway, cube root of 27m to the 30, there's the drawing. 3 times 3 times 3 gets you the 27. M to the 10th times m to the 10th times m to the 10th gets us m to the 30th. And so we're working with the cube roots. And the cube root of this one is 5x cubed minus 3m to the 10th. Everything now comes from this parentheses. So I got to get back to 125. I need 25. X to the 3, I need 6 more. That product's minus 15. We'll make it positive 15. X3, M10. So getting this is just effort. Squaring a number, you always get a positive. Squaring a negative gets us a positive. Squaring 3 gets us 9. Squaring m to the 10th gets us m to the 20th. You multiply this out, you'll see 4 terms cancel. All right, we're finding the inverse of a function. And if you got a singleton here, x in the singleton, it's really asking the question, do you know the inverse operations to solving equations in this function? All right, so this x stands for the answers that come out of that. That's a repetitive thing said in an earlier video. What's the first thing you're going to do is you're going to subtract 4. You're going to divide by 2. You're going to do the inverse of ln, which is ln of. Subtraction of 3, adding 3, move on. This is no different than 2x plus 3y. Let's make it 4y equals 20. Using zeros gets us a y value. Using 0 gets us an x. So if 0 is helpful, why don't we make a 0 with negative 7 for x? Well, that's covering this up. So what squared gets you 25? 5 squared gets you 25. So that's got to be a 7, or negative 7 could work with negative 5. There's 2 coordinates. But I could have made the y equal to 2, and that actually erases this term. And I hope you can pause the video long enough to figure out what gets you a 1. In fact, pause the video and go through each problem as many times as you want. Modern technology allows you to replay this. My, oh boy. From seeing coal dumped into a bin in the cellar to, oh, so much change in my life. Oh my goodness. Where am I? I'm over here. I got rid of the y, so I'm solving for x. Well, I think I need 3, so I think I'll throw a negative 4 in there. That gets me 1. I also could get negative 3. So I think I'm picking negative 10. I believe that's correct. All right, so let's get over here. All right. Yeah, you can see everything. Another equation, a singleton. Let's subtract 5. Let's divide by -5. Let's do the inverse of log base 2 of, which is 2 to the. And let's add 4. And 2 to the -1 is a half. I think 4.5 works. Let's see how it works. 4.5 minus 4. Oh, that's a half. Okay, day 1 of this course, we said, what's the exponent on top of 2 that gets us a half? -1. And that's multiplication. I think 5 plus 5 is 10. I'm moving on. 51. The only thing I'm asking here is, do you know the inverse of this equation? 3 to the t. I think that's an exponent. How do you find values of exponents? I hope logs come into play, because we talked about that language on day 1 of the semester. Yeah, and so if I put that there, I think I've created some inverse operations. Inverse of exponentiating is logging. I think they undo each other, and 17 equals 17. ln of 1/10 is approximately, see, 2 times 5.7, 1.6, 1.6.7, so -2.3. How did I get that? Well, I know that 1 is e to the 0. Now, I'm not going to do rule of logs yet. Let's just figure out what 10 is in e notation. 2 times 5, e to the 0.7, e to the 1.6. Oh, that's 2.3. And if I put it in the denominator, I show that with a negative sign. What's this answer? 23 minus 50. That's that answer. Word problem. I don't have the test in front of me. Too bad. So I'll make one up. John puts $500 in the bank, and it triples every year, every 17 years. And he started in 1999. I wonder what I could write as an equation to capture that. I just did. More reps. F of x, x-intercepts. How do you find an x-intercepts? You let your y, which is another way of naming f of x, you let your y's equal 0. So set this to 0. Boy, this should sound like a familiar refrain. What's the first thing I'm going to do? Add 4. What's the next thing I'm going to do? Divide by 12. What's the next thing? The inverse of e is ln of. I'll get my exact answer here, but I am asking you to know that that's approximately -1.1. And the last thing I'm going to do is add 2. I will take that answer, or I will take adding 2 here. I will take approximately, what? 0.9. That would be nice. 2 comma 9. Oh, how nice. Do I remember what I even asked? No. What did I ask? Oh, I changed it over there. That's the last problem. Okay, so name that tune. Name that tune. Okay. Now on the test, I told folks what it is, but I'm hoping you know at this stage what it is. I hope you know it's a square root function. So I got to have x greater than or equal to 0, and I got to turn 2 into a 0, right? I'm not going to take square roots of negatives, so I start at 2. I want 9. How is this thing changing? That's how it's changing. So when I drop in a 5, that is how it's changed. And I know 5 minus 2 is 3, which is approximately, what is a decimal, since we're going to start trig here real soon, and root 3 over 2 is so important. Hope your brain said 1.73, because that's what we're working with. But the square root of 3 plus 9, I don't think takes me to 1. I hope that means a lot more to you now than it did. So I get rid of the square root of 3, which is here. I'm getting my multiplier, so now that's a 1. What do I need to add to 9 to get to 1? I think -8. Wait a minute, I wanted 5. Yeah, I did. I put 5 in, so that cancels. So let's see if it's true. 5 minus 2. Oh, the root 3's cancel. -8 plus, oh, geez, I'm ready to move on. All right, that's that. And now I can unlock the door, go get the test, set up the room, and say bye, because I'm really running. All right, bye-bye. Warm, safe, the whole